So I added another batch here that we can use to draw any images off of our sprite sheet that contains our boss, our shots, fire, explosions, good guys, bad guys, all that sort of stuff can be on there. And we can draw everything in this batch using those sources. Let's just try something out. We'll draw a ship, add a hero position. You know what, let's make a class. For controlling enemies and the main hero character, let's go over to the right here and we'll add a new class called Actor. And we can use this to control any of the characters. I started making this, oops, let's just go like this first. Started making this actor class, which will have the position of the ship, how fast it's going, how much life it has, what the rotation value is, if it's rotated, the source rectangle. I should probably comment this as source rectangle from the sprite sheet. Whether it's invincible, or what we can do here is have a countdown, which is what I always do. I just have a countdown, like put this at 100, for example. And if it's greater than 0, it'll keep subtracting. And for a short period of time, it'll be flashing and invincible. If it's in the process of exploding, we can also set like an explosion duration, and it'll just keep counting down and making it explode while that number is counting down from whatever we set it to down to 0. We could also use this to control the alpha channel of the explosion so that it fades out. I'm going to create a hitbox. We could use a rectangle here, but I'm going to create a hitbox instead that will just kind of simplify the process a bit instead of using rectangles, and we can add our own things into it. And Boolean determine whether this character is alive or not and whether it should be processed. So let's make a constructor here. Actually, maybe we should create the hitbox first so that it's not complaining about this. This should be really easy. We'll just add a class called hitbox. All right, we got that hitbox, top left-hand corner and bottom right-hand corner as floats. This will be more convenient for us than using integers because then we don't have to do any casting. So I can set the left, top, right, and bottom of the hitbox at startup, and that's all this does. And we can check using this contains here against a vector to see if a bullet is inside our hitbox. So we just send it the coordinate of the bullet, and it tests if the bullet is greater than the left side of the box, if it's greater than the top of the box, if it's less than the bottom, and less than the right and less than the bottom. If it is, that means it's inside, so we return true. So it does contain it, and therefore the character should receive damage. If we want to detect whether two hitboxes are colliding, like two characters crash into each other, we can get another hitbox and do that same sort of test where we test if the left side is less than the right side of the other one, and so on and so forth, to see if those two boxes collided. And if not, we'll return false. So back in the actor class, I added this constructor. I set the initial life of each character to be 30. We might even have this so that we could pass in how much life it has at first, and an initial position that's passed in. This you don't even need here technically because it should be false automatically. Everything's kind of initialized to 0. So I added this damage method now, and if the character's dead or invincible, we're not worried about receiving any more damage until invincible reaches 0. Obviously, if the character's dead, then there's no point in doing anything here, so we just return. So we go life minus minus to subtract from the life, and we set invincible to 10, and until it gets to 0, like I said, the character will remain invincible, so it'll flash or whatever until it gets to 0. So let's go back into game 1, and near the top we'll add a couple actors, probably a hero and a boss. Let's go down into initialize, and we'll set the rectangle coordinates for the hero and boss actor. We'll also have to create the hero and boss actor. Okay, so I set the boss rectangle from the sprite sheet and the hero rectangle from the sprite sheet, so where it's getting those images from. And I'm setting the initial position of the boss to be -200 on the Y, so it's off the screen at first, and the boss will come onto the screen to some position. The hero, I got it kind of near the bottom and more or less in the middle. Let's go down to update and add some controls for the hero. So we need some left-right control here. Okay, I added some direction control code here. This will keep track of whether the user's pressing left or right, and that'll come in handy right here where we want to slow down the character. So if the velocity to the left or the right is above 0, well, regardless of what the velocity is of the characters, for the character's X, if they're not pressing left or right, it's going to come down. So it'll be 96% of what it was every frame. It will ease the, or kind of smooth step the velocity of the ship fairly quickly. I thought for the stars or the scrolling and stuff, I'm just going to, instead of using the velocity, I'm just going to have it scroll if they're pushing the direction, just to kind of keep things simple. If the horizontal velocity isn't too big a value, like if it's greater than -6, we allow it to go left faster, and if it's less than 6, we allow it to go right faster. So that's what's going on there. And then down here you can see we're adding in that velocity to the position in each frame. If the position tries to go off the screen, then we set the position to the boundary of the screen and change the velocity to 0. Same thing with the right side boundary. We have to add on this minus width of the ship because the coordinates of the ship are the upper left-hand corner. So if the upper left-hand corner is all the way at 1024, the ship would be off the screen. That's why we got this subtraction here. Same thing here. So let's go down to draw. And for now, I'm just going to use the simple draw from the source rect, the hero.r that we just created. We're using the hero position, scale of 1, no rotation for now, and color of white. We'll try that out. Okay, so if I push left, it smoothly slows down. We might even want to increase how quickly it slows down and speeds up. But that should be okay for now. I notice when I'm testing this that the far background and the mid background are moving in the wrong direction. Now that would make sense because this one's rotated 90 degrees, so that would mean we have to go negative on this one. And this one's flipped horizontally, which would mean we'd also have to go negative for this one. This one's not flipped, so we should be able to just leave it. Okay, that's better. Maybe I'll change the starting location of the far background. So because scroll X is the other way, I switched the scroll X start position to be -80 instead of positive for its start position. Alright, that looks good. Now let's see if we can do something cool, like make the spaceship turn as we go left and right. So we could use the horizontal velocity to determine how much it should turn. Maybe a float value, we'll call it W for warp. And we can warp the positions using the draw distort, or we could just use the rotation value. So let's first try the rotation value, vel.x, and maybe divide by 8, just a little bit of turning. So we'll use this as a rotation value here. Try that out. Okay, that's quite a lot of rotation. Probably a lot more than what we'd want. So we'd probably want to divide that by like 32 or something if we're actually going to rotate the ship. I'm going to try warping the points bigger and smaller to make it look like the ship's kind of banking on the turn. To do that, I'll use quad.draw. Maybe we'll use color distort. We can make it a little darker at the back of the ship and a little brighter at the front maybe, just for fun. And I'm going to use hero.r as the source rect, hero.position, vector2, we'll just scale by 1. So maybe I'll make another rotation value here that's not as strong. We'll call it M for magnitude maybe. And we'll go maybe 20. Oops, this should be a comma. Alright, so M, it's going to be, that's a rotation, right? Yeah, M. Start a new line here. And new vector2, minus 20. And for the top right corner, we'll say new vector2, positive 20, minus 20. And bottom right, we'll say new vector2, positive 20, positive 20. Bottom left, be negative 20, oops, negative 20, and 20 down. Say color.yellow for the front of the ship, color.yellow for maybe both sides of the front of the ship. And maybe we'll make the back of the ship dark blue. So we're kind of tinting it. Okay, first I'll just check to see if that's working. It's using offsets for the distortion, even though we're not distorting each one differently. So it just looks normal. And the back of the ship's kind of a darker blue, the front of the ship's kind of a yellower color than it normally is. I mean, we could even make this corner transparent, which would be really weird. The corner is kind of see-through. All right, let's add on that W value. So this is top left, so when it banks the one way, we want it to shrink in one direction and grow in the other. So going this way, if it's negative, I want to add to it to make the value smaller, so it's scaling towards the center. So I'll say minus W and minus W. For this one, it's 20 positive, we want to go 20 negative, be positive. We want this head to get bigger, so we want to go minus W. And in this case, this is a minus value. Bigger, we're going to have to go positive W. So I'm just kind of working the math out in my head. So it should make each side scale, like warp a little bit with that W value. It's not doing anything. Let me think about this for a second. Okay, so it's warping it now. And I just had to increase the strength of W. So it distorts it, but because of the shape of the ship, it's not going to give it that proper look like it's being rotated in 3D for when it banks to turn. I would say the distortion thing would be more useful if an enemy is getting hit and you want it to really exaggerate how it looks, or if you just wanted to make trees blow in the wind or something like that. So yeah, I multiplied it by 2 here. So I think what I'm going to do instead, I'm just going to comment this out, is I'll rotate it in 3D. Since we are using the 3D camera, we may as well do that, right? And we'll use the rotate XYZ, so we'll use a matrix to rotate on the X, Y, and Z axes. Hero.position, and this is, we're probably going to have to add or subtract a value to the position depending on the scale. Maybe we'll try scaling by 1.4. We're not going to rotate on the x-axis, that'd be the pitch, but we will rotate on the y-axis. And maybe we'll use the strength of W, which is the stronger one. And then we'll rotate on the Z also. We were rotating on the Z before, by the way. And this one here, this actually rotates on the Z. So that's just turning the ship normally. But we want to bank too, so that's why I put this W in here. And then we'll say, oops, color.white, and no, for depth. We're not going to set the depth. Alright, so let's see what that does. Whoa, we're spinning the ship right over. That's really cool, but I just want to bank a little bit. I don't want to do barrel rolls. Although it would be really cool if you go left and right and it does barrel rolls while you do it. So instead of W equals velocity x times 2, I'm going to say divide by, we'll go with 8 like we did before and see what that does. Yeah, it looks alright. Looks a little bit off kilter. We made the ship 140% its original size. I'm just gonna subtract somewhere around that difference in the position here. It's hard to tell, but that does look more accurate. You'll notice it looks the same on both sides when you hit that angle. Because it's a flat image, it's not necessarily going to look quite right when you turn it, because it's not a 3D model. If we showed the whole rectangle, though, you'd see that it is in fact a quad that's being turned in 3D space. So I added this draw additive sprite section here so that I can add the flame, which I'm drawing, and we're going to need to add a frame number for the flame and update it in the update. And I just added in this offset. It's kind of a rough guess as to where the flame should be relative to the corner of the ship. We may have to adjust that, and we might have to use one of these scaling values depending on how much the ship's turning to adjust this horizontal offset here. And I'm rotating the flame by M, the same way we're rotating it on the Z-axis up here. So first let's go up to update, and we'll go up higher and we'll add that frame in there. So in update, the only two places we're going to use frame is going to be update and draw. So I'm just going to put the frame value here. Set frame, it'll automatically be set to 0. And we'll want that frame to go up to the maximum frame and then back down. So it's going to need a frame direction. So at first it's going to be adding 1. When it gets to the end, it'll start subtracting 1. So it'll have to change that to -1. Okay, so now that we got these here, it'll keep track of them all the time, and we can go down here, and I'll just add some code here. All right, added this propulsion section here, where I add 1 to the frame each time it goes through the loop. If it gets to 3, so it's 0, 1, 2, 3, if it gets past that, it's going to set the direction to -1, and this will start counting from 3 back down to 0. And I set the frame to 2, because we can't have it at 4, because that would be a frame 5 technically. Same thing too, if it goes under 0, it'll be -1. We've got to set it to 1 because it's already done 0. And then we set this to +1. And that should make it go back and forth between those frames. So we'll try that out. Okay, so we'll need to adjust the position of the thruster, the fire. Make it a little bit more to the right and a little bit more down. So I'm going to try 40 and 100. Looks good. Maybe down just a tiny bit more. And we'll have to adjust by W somehow. Changes to like 105. And subtract the W amount here, which we're using for our banking. It's a little stronger effect. And so but it's going to have to be pretty strong to move it far enough, so maybe we'll try W times 4 and see how far it moves it. Not quite far enough, I think. We'll try, I don't know, we'll try 15. It's pretty strong. Oh, closer. Not quite far enough, though. Try 30. That's really close. Maybe just a hair more. That looks right. Let's add so you can shoot some bullets. Go up into update, and before propulsion, I'm going to add this shooting section so that if the user presses space, for example, and maybe we can shoot up to, this is kind of optional, we'll allow shooting up to 100 bullets at once. Now let's make a list of shots, and the shots will have to be a bullet type. So we'll have to make a bullet type. Alright, so the plan is, up here where our variables are, under actors, I'm going to add a list of bullets. So I'll call it bullet, and we'll have to make a bullet class for that, which will hold our bullets. And we'll have shots, and we'll have boss shots. I'll just call them bad shots, because there could be other bad guys too that are using the same type of bullets. Okay, and I'm just going to grab this, and we'll make a new class called bullet. We'll go over here and add a class called bullet. Alright, so here's our class. It's just a vector 2 for position, vector 2 for velocity. We could add stuff later too, like if it's a certain type of bullet, it could be a different color, it could have different damage amount. So we could just create a variety of different attributes that we could add to our bullet if we need to. But for now, it's really simple. Now we'll just have to go down and initialize those bullets. Right after this, I'm going to say shots is equal to a new list type bullet. Oops. And the same thing for bad shots. Let's go down into update. All right, in our shooting section again, let's start a new bullet. We could call it bullet, or we could call it POW, just to make it shorter. New bullet, just allocate it. And we're going to add it into the bullet list after we set its attributes. So velocity will be the hero velocity plus the bullet's velocity. That way it's adding, well, you know how physics works. So, now what did I do wrong here? Oops, don't forget to put the new in front. All right, and POW.position. We'll start it off the hero position plus hero velocity again, and plus a offset so that it's on the end of the ship. And we might have to play around with this value. Start around 40, and maybe to be more in front of the ship, maybe around -10. And we'll add this new shot that we created so that we got a reference to it in our list. We'll add that to the list. And I just paused it a second and added this bit of code here where it goes through all the different shots and it adds the velocity to the current position. If the shot's Y position is higher than the top of the screen, around -60 off the screen, then we'll remove a shot at A, so whatever this shot is that we're looking at. And because this one's gone from the list, I'm going to say A minus minus because everything's going to get pulled back one, and then go continue just to make sure that we aren't doing anything we don't need to. So just to make sure we reset into this loop. All right, let's go back down into our draw, probably in the additive sprites section. I'd say let's make the shots in front of the flames. We'll go for A is equal to 0, oops, and A. Okay, just pause it for a second. All right, I just added this section of code and I played with these values a little bit. I'm scaling a second one over top, making one a light blue, one more of a blue. This one's scaled to 1.4 in size, and because of that I have to offset a little bit to make sure that it's centered still. But this is effectively what we get now, where we can hit the spacebar and make shots come out. Now, it doesn't look like it's quite centered still, so I'll have to fix that. Okay, going back up to where we had the update where we hit spacebar, I just played with this a bit and I found out that if I put this at 46 minus 12, it seems to start the bullet off pretty close to the right position. I would say exactly in the right position. And you'll notice that bigger one's slightly closer to the ship. That's deliberate because I'm trying to make it look like it's trailing. The shot's trailing a little bit, where the brighter part's kind of at the front of the shot. If we go into update, let's bring in the boss and have the boss come on the screen. We'll go under propulsion here, and we'll say if the boss is alive, like if boss's amount of life is greater than 0, so maybe not necessarily dead, maybe he's in the middle of blowing up. If he's blowing up or something like that, we don't want to process the AI logic. He's just going to kind of stay put. So we'll say if the life is greater than 0 instead of checking to see if he's dead. I'll call this section boss event timing, or we could call it boss logic, and we'll add a boss action, sort of a finite state machine type of thing. Instead of making this an enumerated, I'm just going to keep this simple, maybe have an integer right up above the update. So just because this is an example, I'm trying to keep it simple. These are only going to be used in update anyway, so I'm just going to add these here. I'm going to have a timing between actions and a boss action, so which action it should select. And that's obviously going to be initialized as 0 because this is C#. Okay, so I added some code for boss action 0, and we're going to have to add some things in order to make this work. I want to have a goal position for the boss, so that's where he's trying to get to. So when timer reaches 150, he's going to try to get to this location here. We're also going to need to create an extension of random that allows us to make a next float. We could use double and then cast everything to float, but that's kind of a pain, so I'm just going to add an extension. And while we're doing extensions, we're probably going to need to do aiming, which means we're going to need to find the angle of a vector. So we'll add that to our math extensions as well. I also have it so that if the timer gets to 200, then the boss will start targeting. And I think so long as he's not targeting, so targeting is another action that he can do. So as long as he's not targeting, we can add to the timer. And otherwise, we're going to have some targeting logic down here that allows him to target onto the player. So he'll stop what he's doing with his decision making and he'll just focus on targeting while he's doing that. But in order for this targeting boolean to work, we're going to need to specify that there is a targeting boolean. So I'll say here boolean targeting, which will be false by default. Now, what else do we have to take care of here? We need a goal position that he's trying to get to. So let's go into our actor class and we'll add a goal position as a vector. So I provided 3 new variables here. Goal position, that's where he's trying to get to. An aim position, so when he does his targeting, that's where he's going to be adjusting his aim. So if the aim position is too far to the right of the player, he'll move his aim position more to the left and vice versa. The aim vector will be composed of the aim position minus the actual position of the character to kind of get a vector of trajectory that the bullets will fire. So let's go back and adjust that logic in game 1. Oh yeah, we still have to take care of adding a next float. So let's go over to the right here and add a static class. I'm going to go add class and we'll call it extensions. Okay, in order for this to work the way we want it, this has to be a static class, and then we can just use these methods anywhere we want. So I got this public static float, and so now if I have a floating point, I can put .toAngle on the end of it and supply the vector that we want transformed into a float angle. And what I can do is use this atan2 to get the angle based on the y value of the vector and the x value of the vector, that opposite over adjacent sort of thing. And also supplied this next float here so I can use a floating point between a minimum and a maximum value, and it's basically just going to supply this. If we wanted, we could use aggressive inlining here too. Since these are very small methods, the compiler probably will be able to figure out how to just substitute this code in there in place of what we're using here. And that way it doesn't have to pass into a method. It's a little bit more efficient. So the goal position is basically the center of the screen, which is 512, minus half the boss's width. So I figured around 420 is where he should be when he starts. And I'm setting a randomized position for the destination so that it's not always exactly the same. It might be somewhere between -300 and +300 in the horizontal position. The vertical position to start off with, I'm just going to set it to 50. I'm not going to vary that one. All right, so we're going to need something for targeting once targeting becomes true. So let's go down here. Actually, you know what? The first thing we're doing is we're trying to get to this goal position. So we may as well do an update so that he's interpolating or easing into that goal position. So what I added was this boss position is going to be equal to the current goal position minus, and what we have here is the difference between the goal position and the boss's current position. And I'm going to take that distance between those two and make this value 95% of that. So if we subtract that value from here, this will be effectively 5% here, right? Because this is we want to be 95% back from the goal position. I mean, you could do it the other way. You could go based from the boss position and do a 5%. Hopefully that makes sense. We're just getting 95% of this distance each time, and we're subtracting from the goal position. And that way he'll smoothly blend from the current position to this goal position. Now, if we want, we can go down into draw and add in the drawing of the boss so we can actually see this working. So after this line, I'm going to add in if boss, I'm going to say if boss.life is greater than 0, then we can draw the boss using the source rect, boss position, scale 1, boss's rotation, because we're going to use the rotation probably for the targeting, and I'll say color white. Let's test out what we got so far and see if he drifts into position. Okay, we got that much working. Should probably initialize the boss's goal position too, so that it's the same as the boss's starting position. Not that it really matters that much, but about here, right after we create the boss, set the goal position to be the boss position. And then when it reaches that timer as 150, it's going to change the goal position to be on the screen somewhere. And back down and update inside this boss life greater than 0 loop, or section I should say, down under the switch, let's add something for the targeting. In fact, you know what, let's take this code out of here and put it here, because we only really want to do those calculations if the boss is alive. And we'll do the targeting here. If targeting, we'll say if the boss.aim position x is less than the hero's position, x position, then we'll simply say boss.aim position x plus equals 10. And we'll do the same for the other direction using an else. Otherwise, we say if the aim position is greater than the hero position x plus 64, then we want the aim position to target in the other direction. Otherwise, if it's between the left and right side of the character, he's done targeting. So he can go to the next action. So I say boss action plus plus, and I set targeting to be false. So then we could go up here and start adding a case 1 and a case 2 and that sort of thing. While he's updating the aim position, we got to make sure we adjust the actual aim vector, which is the direction the bullets are going to be fired at. So aim vector is equal to the boss aim position minus the boss's position to make that vector. And so we can calculate the boss's rotation so that he's looking in the direction that he's aiming. by saying boss aim vector to angle. And you may have to play with this value, it depends on how your character's rotated or how it is in your sprite map. I'm aware from experience that this would be a 90-degree adjustment, a negative 90-degree adjustment, so negative 1.57 F. And we should see him rotate in the direction of the character now. So I'll just try that out. Let's go over to the side here so he has to aim this way. He's targeting way the wrong way. Not sure what I did wrong there. I just realized up here we haven't set anything to do with the aim for its initial placement. So let's make sure we do that. So I'm just setting the aim position to be the same as the goal position of the character. Same XY location, but then I want it to be down further from the character, so towards the bottom of the screen. So his aimer is going to be initially under him all the way to the bottom of the screen until he starts targeting and aiming towards the character. Then it'll just adjust the X of the aim position. Let's just put this up here. Okay, it looks like he effectively targeted my player. So for the next boss action, I added here case 1. Should be firing shots because he's done aiming. And if the timer is divisible by 15 with no remainder, so every 15, 30, 45, 60, intervals of 15 basically, we want to add another boss bullet, so long as he's not in the middle of targeting. We could change this too if we wanted and allow targeting as well. And if the timer does become greater than 350, we're doing the same thing we did above effectively, except we're setting his goal position to be on the left side of the screen a little bit further down and kind of randomizing the offset from that position a little bit. And note that it's going to be adjusting this every frame until it gets up to 400. When it gets to 400, he'll start targeting again. So he won't necessarily stay 100% put. He may start moving around from that, deviating from that position a little bit. To make a boss bullet, we could basically copy the code that we had here. So I'm just going to do that and modify it for a make boss bullet method down below. So let's just uncomment that I put in, and down here under the update, let's make boss bullet. So in making the boss bullet, I set the velocity to be this aiming direction divided up into 100 pieces. So obviously we wouldn't want it to be the aim vector because in one frame it would already be across the screen. So divide by 100 to slow it down. If you wanted to make it really slow, you could say divide by 1000. So this just depends on how fast you want your bullets or how hard the enemy is maybe. Now we'll have to also update the bullets in the same way that we did up here. So let's copy this and modify it. Basically it's exactly the same except we changed shots to bad shots. And I added this comment in here to remind us that we need to add our collision detections in here to see if these bullets are inside the rectangles of each other. So that's those hit boxes. We'll go down into draw now so that we can draw the bullets of the boss as well, and that'll be in our additive sprites. Okay, I just added this code here, and the only difference here is I'm making these shots bigger. 2.4 here instead of 1.4, 2 here instead of 1. This one's more yellow for the bright part, and red for the sort of a more reddish tint for the trail. Since it's blue, that should make it more like a purplish, I'm thinking. We'll have to try it out and see. Might want to adjust this, I'm not sure. I'm thinking it'll still probably look pretty blue though, because we didn't use a very gray looking blue, so it's harder to colorize it. So let's see what we got. It made it green. That's kind of cool, and it's coming out of his shoulder, which I think is okay. We could pretend there's a gun inside the shoulder. Go back up to our update here in the boss event timing or boss logic, and I'm going to add a couple more cases here, just continuing on with different boss actions. So maybe one on the left side of the screen, which is this one, and maybe one on the right side of the screen, and then maybe he just loops back to doing the same sort of thing. Just depends what we want to do, how many actions we want to add. So this is the same as this one up here, just to vary it a bit. I'm making it so that there's a little bit more space between the bullets by increasing the timing, and I just kind of randomly picked a time to change the new target location, randomizing the location a little bit until it gets up to 530, so it kind of drifts around to that spot a bit. And then when he gets up to 530, he'll start targeting again. When it's done targeting, he'll be able to make more bullets again, intervals of 15 again, just depends on what you want. When he gets up to 690, changing the location again. This one here, you can see I went to the right side of the screen. Here we're going back to the middle, more or less. A little bit to the right because we're not accounting for the width of the boss. When the timer gets up to 740, we're going to set targeting to be true, but we're going to reset the action, the boss action, to 0 and the timer back to 0 so that he can restart all this activity all over again. What we don't have though right now is accurate updates of the hitbox of the character or the boss. So let's go down under here and set up a hitbox for the boss. And we'll say boss hitbox, and we'll set his hitbox to be equal to new hitbox, boss position.x. So I need it to be partly into the boss, maybe 20 plus 20, boss.position.y plus 20, comma boss position. It'll depend on your boss. So we'll actually use some rectangles to see where those hitboxes are landing, and then we can make an adjustment. So plus width, maybe times 80%, boss position.y plus boss.hard.height times 0.8. And I'll just do the same thing for the hero, except we'll do that under here because we don't care if the boss's life is greater than 0 for setting the hitbox for the hero. So I'll say hero hitbox. Okay, and I added this hero hitbox, kind of guesstimating as to how far into the character it should be and what percentage of the width and height the right and bottom of that hitbox will be. Once you got that, let's go down into draw, and I'm just going to add a couple of rectangle drawing right here so we can see whereabouts those hitboxes are. I'm not using the hitbox values, I'm just putting these in manually, making sure that they match up. Basically just copied and pasted. Plus 30, plus 20, 80% of the width added on, and same for the height. And did that for both the boss and the hero. So we'll see what that gives us for now. I'll have to play with the values. I'll probably pause it, play with the values. Let's see what we got right now. Okay, it looks like we got to go a little bit further than 80% to the right. And his could be a little bit bigger, maybe. More to the right. And we're not axis aligning his either, so I mean, it might even be better to use radius detections since these are rotating. But I think for this example, this should be fine. Okay, I'm just going to adjust these a bit, and I'll be back in a second. Okay, so I got hero as 30, 20, 86, 86. I got these in a different order here. And this one's 32, 22, 85s. So up here I got it matching 32, 22, 85. Like I said, I probably should just be using the hitbox values for drawing the rectangles. Could do that. Let's test this out and see how that looks. It looks like it matches up really well. Let's go up to our shooting section in update, and where it says do collisions here for the hero's shots, if the boss is not dead, so we'll say if not boss dead, then we can go ahead and waste some time with some collision detections, because if he was dead, that would be a waste of time. So we'll say if hitbox contains the shots A dot position, and we don't want the top left hand position, we want the middle, so we're going to have to add in the middle amount. So let's add in a vector for the middle of the shot. Scroll up to init, and I'm just going to add right here. Probably should add up top, but I'm just going to add right here. Shot mid, and then down here under flame, I'm just going to put shot mid is neuter to the shot width divided by 2 and shot height divided by 2. And then we can add that in, and it'll be more centered. So here we can add plus shot mid. Oops, shot mid. We've done a collision detection. We found out that this shot did in fact hit the boss. We'll call a boss.damage method. And we may as well remove the shot because this shot's hit him. So we'll remove at A, and go A minus minus, continue. Let's just put this on one line so our code doesn't get too long. Alright, yeah, I like that better. And you know what, we can copy this exact code and just paste it in here and modify it so that instead of boss, we'll say hero, hitbox contains, and then this would be bad shots. His are scaled, so let's say shot mid times 2 because they're twice as big. And instead of boss damage, this would say hero dot damage. Again, this would be bad shots removed. And if you look back in Actor, we had this damage method. He's not dead, not invincible. Subtract some life, set the invincible countdown from 10, and we'll use that to create the flashing effect on the character to show that the character is taking damage. So let's go into game 1 and add that next. If we go down into the draw method, let's add a default color. We'll call it col is equal to color.white. So 100% of all the channels. I just put this stuff with a region around it so I can hide it, but in case we want to look back at it or do something similar to this, we can just borrow from this. So this is for drawing the hero. Let's say if hero life is greater than 0, then we'll do this stuff. And in here, we'll say that color is equal to hero.flash color. So we'll make a method that'll calculate what the flash color should be. And that way we don't have to show it in here. And we can customize it based on what character it is. So we'll go to the actor and we'll add in a flash color thing. Okay, I added this flash color thing in here. I know it'll work good because we got the frame rate locked at 60 frames per second by default. So for every time we got a number that's a multiple of 4, it's going to set the color to red, or if it's a multiple of 5. And if it's a multiple of 8, it'll be purple. If it's 9, it'll be purple. So we got some variation in the color. If invincible is less than or equal to 0, it's just going to return the default white color. And otherwise, it's going to count down the invincible number. So this is how it determines what colorization to use on the player or boss, depending on who's using this. So we got the flash color here, and we just got to make sure we change this over here to actually use it. And we can do the same thing for the boss. We can set this to color, but we want to make sure that we're getting a flash color for the boss. So we'll say boss.flash color. All right, let's try that out and see if we can see any indication that we're doing damage. Okay, yeah, we're damaging each other. Oh, apparently I wasn't doing damage there for a second. Looks like sometimes you can't see the flashing, so we might have to fix that a bit. I guess since we know Invincible's only ranging from 0 to 12, we could change this to be, say, if Invincible is less than 4, for example. So I'm just going to modify this a bit and test something out. Oh, let us make sure that if the hero's dead also, if not hero dead, then we can go ahead and process this. Okay. Oh, I just realized we got a major bug in our draw method. If we come down here, I'm just using this method without assigning the color to it. Color is equal to boss.flashColor. Otherwise, it's going to be borrowing from whatever color was calculated here. Okay, so I can go back into Actor. I'll put this Invincible back to 10. I'll leave that as it is for now. See how that works so far. Yeah, it works good. So it should stop drawing them as soon as one of these are defeated. Now let's make it so that our flame goes out too. If hero.life greater than 0, then we'll draw it. So let's add some explosions. Go back into Actor, and we're going to use this explosion countdown here, kind of like with Invincible, except we're going to use this to track our explosion progress. So let's go into damage. We'll say if life equals 0, and I'm going to say equals because I only want this to be triggered once, so if it's counting down still for whatever reason, this will just ensure that this is only going to set it to some amount once. So we'll say 240, pick a random number, and if life is greater than 0, and we could make a little mini explosion happen if the ship gets hit. So just one little puff. Well, maybe we'll do that after. So next up, I would suggest we need a method that we can check to see if there are any explosions happening, and if not, it'll return, and otherwise it'll draw the explosions. I'm just going to process everything in here all at once instead of doing an update separately for it. All right, let's go with, like, we probably should have our explosions being something that's generated and stored in a different method, but this will be fine. All right, so if explosion countdown reaches 0, or we've set the character to be dead for whatever reason, we'll just return. In the meantime, though, if the explosion amount is greater than 0, then we'll do the countdown. Now, if I want to add little explosion puffs, I want those to get processed too. And I want the explosion to control the alpha. So maybe once it gets close enough to 20, or even let's say, well, if it reaches 40 even, because it's going to be pretty invisible by then we'll say dead is true, and we'll set explosion to be 0, and we'll have to clear out any explosions, but we don't have anything that tracks explosions right now. So let's create an explosion type, just something really small that we can handle in here that specifically works with this actor class. Maybe I'll just put something right here. Just a little structure or something. We'll call it boom. Just a little mini class. All right, I added this position for the explosion, a timing. So I got time and a frame. Probably should have put this as a separate class file, but it's getting a little bigger than I expected. And we're going to update each explosion, taking a base position, that's the position of the character that it's relative to, a width and height value for generating the new explosion positions, so kind of the range that the explosions can appear in. And we're going to increase the time value. If it's bigger than 4, then we can advance the frame. That's what it's going to draw. So we increase the frame, reset the time, and we need to handle if we go past the end of the number of frames. So if it's greater than 4, sets frame back to 0. And I could just have it remove this particular explosion from the list, but I decided I'd just reuse it. So I'm just resetting the position, resetting the frame, resetting the position to be the base position, so the character position, plus some random amount horizontally and vertically for where it should be, kind of scaling it a little bit smaller than that range, so it's inside the character. Subtracting 32 from it because that's half the size of the explosion, so this kind of centers it a little bit better. And then for drawing it, I put this color in here so we can use the explosion countdown as an alpha channel for our color, so we can just feed that in here and then draw it. And I decided to scale it by 2 here. That's why this is 32 instead of 16. And we'll be able to draw the explosion frames from any of our methods. We don't have to pass them in or anything. That kind of makes it handy, especially if we've got a whole bunch of particles and lists and stuff all over the place using it. So I just get it from game 1. Basically, that's why I made it static here, because I knew it was going to become a problem. All right, so that's it for that. Now we just got to take advantage of it down here. But before we can take advantage of it, we got to add it to our actor class. It'll be private, and I'm going to say boom, the list of booms. I'm just going to do like that. So booms are really our explosions. And let's allocate some memory for that list. So I'm adding some logic here now for the creation of explosions based on some time amount too. So let's just go here, int timer, say draw explosions. So if the explosion is greater than 20, then we're going to process this. So the countdown hasn't reached 0, and it's between 20 and 1. I have this idea that if it's somewhere between 20 and 1, we're going to create little puff explosions later on in the damage. So we're just making sure that we're only generating new explosions if it's some higher value, so that means it's the final explosion of whatever character or thing this is. So keep adding to timer. If timer is greater than 8, then we can add a new one. We'll reset timer to 0. If there's less than 100, then we'll spawn a new one. And here I also check if it's 5. If it's come down to 5, so if I got a little puff explosion, let's say I start explosion at 10, and I just realized this isn't making sense here. We can take this out of here, put it here, but we're not adding any of those little bursts yet, so maybe we'll just leave that out for now completely. So we'll make a method called spawn boom down here, and that'll just spawn the new explosion. So this creates a instance of boom, places it at a position, kind of randomly within some range, based on the rectangle width and rectangle height of the character, scaled by 80%, and then offset so it's more centered. So it's the same idea as what we did above, and then adds it to the list. Now we should also process our explosions, so let's go if character's not dead, then we'll process them. Say for a equals 0. I'll just type this in real quick. So as we loop through them, we'll make sure to call the update, which will update the frame of each specific explosion individually, and recreate its position if it's finished animating. So as we loop through these, we call that update, supplying the position and the rectangle region that we want the explosions to respawn at if it's going to make a new one. I'm saying here if the explosion is less than 21, that means that we're doing one of these little puff explosions that I'm going to add into here. Then we're just going to draw it at full opaqueness, so alpha will be 255. Otherwise, we'll draw it so that the alpha and the blue and green channels go down with the explosion, so it kind of turns into a dark smoke and vanishes as the explosion amount just goes down. The red value stays at 100%. We could even say the explosion value goes down by half the amount, like if I said divided by 2 or something here. Or wait, no, we don't want it to go down as fast. So I guess you'd have to say something like divided by 2 plus 128, something like that. That would do it. So since we kind of have a case here for handling those little mini explosions where it's not blowing up the whole character, let's try to add that into damage so we can spawn just a couple little explosions or whatever, and say if booms.count greater than 1, then we'll clear it, because this is just receiving damage. The character's not dead. So if there were a bunch of explosions still in the list, this will just make sure that it's cleared to 0. So there could be some left over from an explosion event from a previous or a reused boss or something. We're just making sure that list is empty so that when the alpha is back to full visibility, there aren't suddenly a bunch of explosions that shouldn't be there. So we'll say explosion value equals 5 maybe. So that's under 20. So this will be a very brief explosion, maybe yeah, 5 should be okay. So it might not even show all the frames. It might only show like the first frame or two. But that's okay because we just want a really brief kind of flash to indicate that something hit the ship. And we'll spawn a little puff of fire wherever the ship or enemy ship got hit. Well, I noticed our list thing is underlined. Let's go quick actions refactorings using system collections generic. Okay, I'm gonna hit F5, see if this works. Okay, the puffs are not working, so I'll have to figure out what's going on with that. See if the explosions work. What did we forget? I think we forgot to call our updates and stuff. This is actually a really obvious bug. We didn't call draw explosions in game 1 in the draw. Oops, gotta say hero draw explosions. Pass in quad batch to draw. I'll just say if any. It'll return if there's nothing in there to draw. And same with the boss. So it'll check to see if there's any explosions, and then it'll draw them if there are any. It'll update and draw. So I'm kind of doing this all at once instead of having an update up here and a draw up here. It's probably better though to actually have your updates in update, and then all your drawing just kind of happens all at once, because you kind of want to minimize anything you're doing with your draws and keep most of your calculations and input and stuff separate in update. Okay, we got some little puffs working. Kind of 2-frame puffs. And let's see which one of us is going to blow up first. Okay, I got him. And the alpha works, it fades out. Good. Let's make him reset so that we can fight him more than once. So in update, we'll add this. Just for fun, let's reset the boss if he's defeated. And if boss dead, oops, dead, then we'll allow it to reset. I got these globals, which are technically kind of local to update, and that's for the boss logic. So the boss action for the finite state machine, boss action, whether he's targeting or not, and the timing between actions. I reset those, but I want to reset the boss internal variables as well. And I'm going to supply a new spawn location for the boss, some random amount horizontally and at 480 minus 300, so he's off the screen at first. So we'll go into actor and we'll make a revive. We could also take advantage of this for respawning the main character too. Obviously we will want to change this to be the center of the screen and closer to the bottom. But let's go into actor and add a revive, maybe under this spawn boom thing here. Actually, on second thought, let's go up here so we can see all the different things that we might have to reset. Maybe right under the constructor here. We'll add a revive that resets everything at a new position. Okay, I paused it again because I didn't want to make you sit through me typing this all out. So I reset the life to 30. You might even want to make that a revive variable. Dead has to be false, obviously. So basically I just went through the checklist of everything that's here, reset the explosions to be cleared, and made sure everything's where it should be. The goal position is kind of lined up with the character. The aim position is somewhere down below the character at first. I mean, we could even set this to 700 or whatever. Yeah, I have the aim position being the same as the character's position, so it doesn't really matter at first. That first boss action is going to determine the aim position right away anyhow. So now, if we defeat him, he should respawn and start attacking. And kind of part of the fun of making these types of games and working on them is just trying out each new little thing that you make, even if it's something tiny like respawning the character. And he should come onto the screen. There he is. There's a new one. I should make sure that my guy can get destroyed. Yep. Now let's add some sound effects. Go into content, and I'm going to add a couple of folders here. I'm going to add one for sound, and I'm going to add a folder for music. Then I'm going to right click and add an existing song. I'm going to add, I think I'll add a couple songs. These are ones that I made, so there's no copyright infringement. And good to remember what you named them so you don't use the wrong file name. Keep in mind what kind of capitals and stuff you're using. Same with the sounds, you don't want to use somebody else's unless you have permission or it's royalty free. So I'm going to add my own. So I'm adding 8 different explosion sound varieties to make it sound a little more cool, and 4 different shot sound varieties. This tutorial, by the way, or this part of the tutorial, the sound class that we're going to make, is actually based on somebody else's tutorial. So that's kind of where I got the idea how to make this from. Let's see if I can remember where I got that from. So we'll make a new class called sound. Okay, so you want to make sure to make that class into a static class, and that way we can fetch our sounds and do any sound adjustments we need from any of the modules. We don't have to pass a bunch of stuff around. We can just say sound dot whatever. So I've got something here that tracks which song we're playing. I'm starting with song 2. I'm going to load in 2 songs, so it has a little bit of variety. If it finishes one, it'll start playing the other one. I've got an array of explosion sounds, and we got a getter for the explosion sound and what it does. We got a random selection here based on the length of the array, where it randomly selects which variety of explosion sound to use. And as I said, this is based on an old tutorial that I was following when I was learning XNA. So I'll try to leave a link in the description if I can figure out where I got that from. And you can go check out the original source too. So I'm not sure how similar this is to that source, so I just want to make sure people know that there is another source where they can get more information on how all this is set up. So for shots too, we got an array of shots, and we randomly select which shot to return. So when we want to play a shot, we say shot.play. I'll go into how this is being used in a little bit. So we've got to make sure we load our sound effects. Make sure you're supplying the correct folder and the correct spelling. And this is a trick that I learned from that tutorial where you can say explode sound, and if you're loading a range of sound effects or a range of a specific graphic or something, you can say enumerable dot range, the start number and end number, dot select x maps to lambda expression or whatever. Content.load, sound effect, and then here it's just doing the usual content.load, and this will depend on the name of your sound effect. So these are like 01 to 08. So I add this plus X on the end, and this will just kind of loop through 1 to 8, making this 1 to 8 as it does it, and add this into this array, this explode sound array. And we basically just do the same thing with the shots, going 1 to 4 instead. And when I load it, I set the media player volume to about 40%. That just depends on your preferences, and you could have user adjustment for that if you wanted. So that's just how loud the music's going to play. I got this manage music thing that we can use. If the media player has stopped playing music, so if media state stopped, if the current song's 1, it will set the current song to 2 and it'll begin playing it. The current song's 2, it'll set it back to 1 and begin playing that one. So it loops through 2 different songs. Let's go back to game 1. Also, I'm going to make sure I build these. So an update, maybe under the boss reset, let's add a sound.manage music, and that should start playing the songs that should already be loaded, but we'll have to make sure we load them. So let's go up to load and say sound.load and pass in the content manager. And now we can add sound effects for the shots. Let's go down into update and look for where the shooting is. Wherever a shot's added, we'll say sound.shotplay. Whatever volume you think's reasonable. I'm going to set it to 80%. Pitch, that's whether it's high pitched or low pitched. 1, I believe, is normal. The panning amount, so this is a hero shot. So we'll use the hero's horizontal position with a pan method, but we'll have to create a pan method. So this will fetch what it thinks the panning should be based on the hero's X position. That's how much volume you have in each speaker. So if the character is further to the left, it'll be louder in the left speaker, and vice versa for the right. Let's go into actor and we'll add a pan, maybe under this spawn boom thing. Okay, at the bottom of actor, I added this pan, and I'm saying the pan is equal to position.x. And if it's less than 0, so it'll be on the left side of the screen, I'm going to say it's 0. If it's greater than 1023, it's too far to the right because we're dividing it by 1024. We don't want it to go past that. We'll say pan is divided equal to 1024. Okay, so this is making it 0 to 1, but we want it -1 to +1. So I'm going to say pan equals pan times 2 minus 1. We'll try that. Now let's go back to game 1 and add some shot sounds for the boss. And the boss doesn't create his shots in input, obviously. We spawn bullets for the boss using make boss bullet. So we'll go sound.shot play. Volume, maybe his are a bit louder, it's bigger, maybe a lower frequency, and we'll use pan to get the stereo panning. Now let's go into actor, and in spawn boom, let's make a boom sound. Go sound, explosion, play. Don't want it too loud, because I think the sounds are initially a little bit loud anyway. Maybe slightly lower rumbling explosion, and we'll use pan the same way for that. And we'll try that out. That worked pretty good. Should have another one now. So, while the explosions are kind of cool, it'd be better if there was like a screen flash and maybe a screen shake. I think we're just going to go for a screen shake, and we'll use that world matrix transform to shake everything around whenever there's a big hit or a big explosion. And again, I only plan on using this stuff with updates, so I'm just going to make it so that I'm declaring all this above update. It's just the way I prefer to do it. Might confuse other team members if you're doing it this way, just to keep in mind. So we'll have an updating shake angle and shake radius. And we'll have the radius get smaller, and when it reaches a certain smallness of screen shake radius, then it knows the shaking is done. So kind of adding things in order, let's go to the bottom of update here. And just before manage music on the bottom of update, we'll add a screen shake thing that controls the screen shake. Maybe we'll set it initially to be vector 2.0. Now, if an explosion just started, like a boss explosion, it was 239, so 240 is what we set it to when we start it. So if it hits 239, it'll trigger the explosion. We'll do the same thing for the hero. Then we'll set the starting shake radius to 8. So if the shake radius is big enough to do any shaking, okay, I added the code for it, and what we got here is we're setting a shake vector. And what this is we're using that shake angle, which is going to increase by this amount each time it comes in here. So it's getting a random float between 0.5 and 1.5. 1.5 is like a 90-degree turn. 0.5 is, I don't know, like 20 degrees or something. So direction is going to change really quickly, but kind of randomly too. And I multiply by the shake radius, so that increases the distance of that rotated vector. So this rotated vector on its own is only a length of 1. That's how this works. It's just creating a spinning vector for how much it should move the screen in a particular direction. And we count down the radius. I'm going with, whoops, this should be equals 8. I'm going with shrinking it by 0.07 per each time it comes in here. And when it gets down to 1, it's going to stop. So you might want to play around with this number. You might even want to play around with the randomization of the angle. Now, you may be wondering, how do we add this shake angle to the world transform for our begin? We'll do that next. Actually, you know what? Before we do that, let's make it so that we kind of experience the feeling of getting hit with a tiny screen shake each time a boss bullet hits us. So let's go to where our boss bullets are, right here. And if this hits us, we could add a shake radius that's significantly smaller of 3. So you just gotta get a little bit of a pump. Let's go down to draw, and we'll add, maybe up here somewhere, quad set world. So this is going to set the world transform for everything that's drawn after this, using quad. And using that set world that we made, this way we don't have to feed it into each begin. It'll just make it here and keep it. And we'll say screenshake.x, screenshake.y, and we're not going to bother with the Z amount, even though we are using a 3D camera. And I think that'll work. So we'll hit F5 and see what we get. Yeah, we get a bit of a shake when we get hit. Now you should get another spawn. I'm not very good at my own game. I haven't died yet, though. I don't have any points, so we could add something like that if we wanted. Power-ups, so you can get a cooler looking shot. Maybe have more waves of guys. Even some simpler guys that aren't quite as smart, that just come across the screen and in waves that you don't have to dodge or attack. So I suppose next we want to turn off the hitboxes. We don't really need them now. That's just a matter of commenting out these 2 lines here. We'll keep them though, because we might need them for later if we're doing something else with collision detection, so we need to figure some out. I doubt we'll need it though, but I'm just kind of keeping it for now. It'd be kind of cool too if we could speed up and slow down and then have the nose go up and down a bit. I'd maybe make it so that when you blow up some of the bad guys, you can collect something, and then when that, you can collect like a power up, but it doesn't automatically give you a special shot. But when the bar gets full for each type, like if it's a red type, green type, or whatever, when it gets full, that gives you your power up. So then you kind of have incentive to shoot a lot of bad guys. You got a little bit more incentive than you do if it's just for points. We could also too have the timer set up, like another timer set up, so that our environment changes over time. So we start entering asteroid fields, bigger bosses might come, which will be running in their own class. Maybe the background will change. We could give this guy cooler weapons too, really. I mean, he looks really powerful. Maybe make it so that some big energy ball appears right in the middle and then shoots out after it charges up. I think I've fooled around with that long enough. Make sure to save everything.